All right, Amy, let's take a look at those two. So number 7 on the linear equation says this. It says x minus 3 over 5 minus x plus 4 over 3 is equal to x plus 5 over 15 plus 6. On this one, I want to say I put a star next to it on your all's midterm review because that one is going to be extra credit if you have one like that on the midterm. So I'm looking at yours right now. Yeah, and I did put a star on it on the answer key. So that's why, because it's going to be extra credit. So what happens on this, very similar to what we've been seeing before with the fractions, we have to have a common denominator in order to solve this. The common denominator out of 5, 3, and 15 would be 15. So that means I can multiply this whole side by 15, and as long as I do the same thing to the other side, it'll keep it equal. But that will then allow me to remove those denominators. So looking at those one at a time, starting with 15 times this part, so I'm just going to write that separately so you can see what happens to that. That's over 5. What happens is that allows me to cancel out the 5 because that means both of these will be able to be divided by 5, and 5 divided by 5 is 1, so therefore that bottom number is just going to be eliminated, but make sure we take 15 divided by 5 as well, and that's going to be 3. So now the 3 just gets individually distributed to these two, making that 3x minus 9 as that first part. Then, now going back up to the top, we have to then take 15 times this part. Sorry, that's an arrow right there. So that's going to be, and so remember this is a minus between those two, so this is going to be 15 times x plus 4 over 3, but that will again allow me to cancel out that 3. So in doing so, the 3 gets canceled out because we can divide both of these by 3, so that again becomes 1, but 15 divided by 3 is 5, so now that 5 gets distributed. So 5 times x first would be 5x, and then we can look at that as negative 5 times 4 as negative 5 times 4 would be negative 20. So that's why this would just be this minus 5x, because it is, again, minus 5x. So that's what I would get on that one. And now we then do the same thing over on the other side. So over on the other side of our equal sign, 15 being distributed to that first part, which is x plus 5 over 15. Well, since 15 and 15 are both the same number, that means they can both be divided by 15. So therefore, that would just stay x plus 5, since those just both became 1. And then doing the same thing to the second part, 5 times 15 times 6 would be 80. So the next part to this would just be plus 80. So then there's what we're left with down here. I'm going to go ahead and eliminate all of that distribution out of the way here because it looks super crazy confusing. So I'm going to go ahead and just rewrite what we were left with, and that was 3x minus 9 as that first part, minus 5x minus 20 as the second part, equal to x plus 5 plus 80. So now, whoops, that's 80. We need to combine any like terms. Again, looking at one side of the equal sign at a time, so I'm starting over on the left. I can combine the 3x and the negative 5x, so that would therefore then be negative 2x. And then I can combine the negative 9 and the negative 20, which would be negative 29. Then going over to the other side of our equal sign, the only like terms we have to combine are the 5 and the 8, so that would be 85. So then over there, we're just left with x plus 85. Okay, so now when we start moving things across the equal sign, I just want to get my variable on one side of the equation. So I'm going to subtract this x from the right side and do the same thing over on the left side. So that will leave me with negative 3x minus 29 over on the left is equal to 85. So now I need to get rid of the 29, so I will add 29 to both sides of my equation to get rid of it on the left. and then that ends up getting added over there on the right. So that means negative 3x is equal to, looks like 114. And then what I have to do to completely solve that, I will just divide both sides by negative 3 to get x by itself on the left. Just do the same thing over on the right. And 114, and I'll just double check it, but yeah, 114 divided by 3 is 38. So that would be, oh, it should be negative 38 then, shouldn't it? Duh, it should be negative 38. Gosh, I'm just brain fart. I did that quickly the other day, and it should be, yes, it should be negative 38. So I hope that helps on that, if that's not what you ended up getting before. I hope those steps helped with that one. So that was number 7. So getting that out of the way, you were also looking at number 3 on the conditional. Oh, I didn't write that one down. Let me see. On the conditional. Hold on just one second. I'm going to find it. Oh, there they are. Okay, so number 3 on identifying whether it was conditional, contraction, or an identity, I got that x is equal, or I'm sorry, y is equal to 8, maybe? Okay, let me take a look at this one. Let's see how we got that. So this one says that 1/4 y minus 5 is equal to 1/8 y minus 4. So what has to happen on this one? This was the one where we can use decimals in place of those fractions, since we can just replace this 1/4 individually, and we can replace that 1/8 individually. We can use the whole common denominator thing. If you need me to show you that, I'd be glad to. But I think in class everybody had said that they were just using decimals, and that was easier. So what that means is you can just use in place of that 1 divided by 4 is 0.25. So you may have used 0.25y minus 5 is equal to 1 divided by 8 is 0.125. So instead you just use 0.125y minus 4. So what we need to do is get our variable by itself on one side of the equation. So I subtract 0.125 on either side. That allows me to eliminate it over there, and that's, again, yes, 0.125y. So it leaves me with 0.125y minus 5 is equal to negative 4. And then what I had to do, I want to get the variable by itself, so I'm going to add 5 to both sides. That will leave me with 0.125y is equal to positive 1. I'm just double checking as I go back and forth here. And then 1 divided by, yeah. And then so what I'll do to completely solve that, I'm going to take both sides and divide by 0.125 to get y is equal to 8. So that's how I solved that one. Hopefully those steps make sense. If you need me to show you using the common denominator method, I can do that too. If you're not using that, you can just stop the video at this point. But I'm going to go ahead and just show you how you'd get the same thing if you chose to use that method too. The common denominator between 4 and 8 would be 8. So that means you can multiply both sides by 8, and that would keep it equal. Distributing the 8 to the 1/4 y would mean that you can eliminate the 4, because 4 and 8 can both be divided by 4, making that 1 and 2. So that would just be then 2y for that one right there. Then distributing the 8 to the negative 5, that would end up being just negative 40. So then we're left with then minus 40. Over on the other side of the equal sign, we would be able to do the same thing. So just rewriting this right here, 8 times 1/8 y. We can eliminate then the 8, since they're both divisible by 8, leaving us with just y on that side. And then don't forget to distribute the 8 to the negative 4 there, so that would be minus 32. So that means to solve for that completely, we would have to add 40 to both. Oh, no, sorry. Nope. That is not what I wanted to do. I want to get my variable on one side of the equation first. So I'm going to subtract that y from the right side and put it over there on the left. So eliminating it from the right side, that would leave me with y over on the left. Minus 40 is equal to negative 32. And then to completely solve that, I'm going to add 40 to both sides of my equation, leaving me with y on the left, and negative 32 plus 40 is very much 8. So that's what I would be left with if I did it that way as well. So hopefully that helps. If you have any questions, please do not hesitate to ask.